Hello, in this video we're going to look at strings and loops, and we're going to start with a quote. Did you know there are potatoes in a potato field? Unknown 2015. Okay, let's dive in. So let's do a really quick general review of strings. A string stores a collection of characters. Those characters can be symbols, numbers, letters. Strings can be added together, so if I say S1 and string S2 and I say S1 plus S2, puts them together. This is a process called concatenation. Strings cannot be subtracted from each other. Now there are ways to give the appearance like we've subtracted letters out, but we can't subtract them. Strings have a selection of methods that can be used, and the documentation can be found here. And I really want to stress this point here. So here's the documentation for the string class. You really want to get to know this. And not just this documentation, you want to get comfortable reading the documentation for any language that you happen to be working with. At this stage, for those of you in my class, we're looking specifically at the methods. We're not interested at this point in constructors or fields, but we want to know how to read this documentation because this allows us to do a lot of really cool things. And we'll look at some of that in this video. So a couple things we want to watch with strings. The first thing is that even if a string only contains numbers, they cannot be mathematically added as strings. So for example, if I have W1 is 3 and W2 is 4 and I add them together, remember, Java doesn't see them as actual numbers, it sees them as strings. So what I'm going to end up getting is 3, 4. It's important to note we can convert a string to an integer by using the parseInt method, which is a static method in the integer class. I won't dive into how this actually works right now. Hopefully by the end of this video you'll be able to piece it together because we're going to talk about static methods very quickly. And it's more of a reminder because we've seen them before. But this would be the line. We use the static method in the integer class, so integer.parseInt, and provided this string is a numerical value, that is an integer, what's generated will be an actual int form of that string. The other thing we really need to watch for is that strings can be compared using double equals, but it will not always work. So you can actually compare strings using the equivalent operator, but it's not always going to work, and we don't do this. We need to use a method to compare strings for equality. So we can either use the equals method or the compare to method. The compare to method is particularly useful if we want to look at alphabetical order. So a really small code segment here, if we have W4 is the, W5 is word, and then we have a Boolean called flag1, and we say flag1 is equal to W4 equivalent to W5, that's fine. That works. If we say flag2 is equal to W4.equals W5, that's fine. That works. Both statements are valid, but W4 is equivalent to W5 will not always work correctly. We're not at a stage where we really want to talk about why that is. It's just really important we're aware of that. It's very often when I'm looking at students' code that something will be funny and then they'll be trying to compare strings in this manner. It's a logic error. It's not a syntax error. It's not a runtime error. So sometimes you won't even notice you're doing it. Let's do a really quick review of methods. Again, don't try and memorize any methods. There are common ones you will naturally remember, but documentation is always provided. Know how to read that documentation. And this goes beyond the string class. This goes for any class that we're using in Java and other programming languages. So here's an example of a method in the string class. There's our return type. So since the word static is not there, we know we need an implied object, and we'll kind of clarify what we mean by that shortly. So this method gives you back a string. That's the name of the method. So the name of the method is substring. Remember, in the documentation, if you actually click on that, you'll jump to a lower section in the page. It will give you a more detailed description and possibly an example. The parameters are what it requires. It's good to note that the types are called the parameters, but what we actually put in there, the values themselves, are called arguments. Parameters and arguments they're two different, they mean different things. They're often used interchangeably. Parameters are what we need. Arguments are the actual values of them. So the parameter here are 2 integers. Arguments could be 3, 9. So an example here, if we have W6 is food, and we have W7 is W6.substring25, and then we print it out. Remember, when we think of a string, we talk about the length and the indexes. So the indexes always start at 0, and they go to 1 less than the length. So if I'm doing substring 2, 5, substring works inclusive, exclusive. So I'm going to go index 2, 3, 4, but I'm not going to include 5, and the result is a string of length 3. A nice little thing to note with substring is that when we subtract the second parameter from the first parameter from the second parameter, we'll get the length of the resulting string. 5 minus 2 is 3. So like I said, W7 will contain OD exclamation mark. And again, remember, substring is inclusive, exclusive. As a kind of thing just to keep in the back of your mind, if you're ever not sure, go with inclusive, exclusive. It tends to be what people use. But it's not always that. And like I said, W6 is the implied object. Again, we're not really interested at this point in really exploring what an implied object is, except for the fact that in this context it means what the method uses in its analysis. So if I just said to you, take the substring 2, 5, you would probably say to me, substring of what? Well, what we're applying substring to is W6. It is the implied object. So let's have a little tangent here about reading documentation, and let's specifically about the word static. We've talked about this again, but it's always good to come back and revisit these ideas. So this is a method in the math class, and what we notice is the word static is next to the return type. What this means is that we don't need an implied object to execute this method. So if we don't need an implied object, we invoke it with the name of the class. So if min is a method in the math class, we go math.min. Now, some students will say, okay, when they're learning this, they'll say, I know all the math class methods are static, so it's always math dot, and then they'll say all the string class methods are non-static, but it turns out there are actually a couple static methods in the string class, and this is one of them, value of. So if I was to invoke this method, I would use the name of the class, string dot value of 56.5. And again, this is just a number I picked and put in there. And value of converts a variable of a different data type into a string. Now it turns out there's a much easier way to do this, and that is just to make some new string and put an empty string by putting double quotes plus whatever value that is. So now we get into like the meat of this presentation, and I'm 7 minutes and 30 seconds in. Anyways, classic type of question is count the number of times the letter S appears. So if this is my string and it stores the word fish, we want to first remind ourselves that its index is 0 to 3. Fish has a length of 4. So you could search this from first to last. So I might look at the F, I, S. Okay, there's one S, then the H. Or I could look at it from last to first. So if I look at it from last to first, I'm going to go 3, 2, 1, 0. And either way I do this, what I'm actually doing is I'm taking my finger and I'm pointing at each letter in sequence and then trying to make a decision of whether or not it's an S. The important thing here is that as a human being, I give this question to you, and you would just very quickly say 1. Well, with this process, we want to break it down to exactly how do we do that, and it's very, very step by step, and it requires me kind of pointing at each character in sequence and looking at it. So let's start by how would we do this from first to last? Well, do you notice the counting pattern with the indices? They go 0, 1, 2, 3. And a loop can simulate that counting process. And we can access that individual character by using the char at method, which is an instance method in the string class. So a little code segment here, we have our string str, which stores fish. We have a counter, and that counter is going to store the number of times that the letter S appears. And then I set up this loop. And what I need to do is specify the parts of the loop such that I walk through and look at each letter in sequence. Now, before I do that, let's remind ourselves. So I'm going to look F, then I have to go there, then I have to go there, then I have to go there. That's what this loop needs to simulate. And the logic inside is simply going to be str.char at I is equivalent to S. Now, please note, I put a small s here and I put a capital S here. I'm not going to re-record all of this for that. I'll just take a note of that. So what I say to myself is, okay, if I'm using I inside this loop, I need to think about how does I change. So I, when I first pointed at F, so I starts at 0. That's my counter. My counter is initialized to 0. Well, how far do I go? I want to look at each index. So I want to go as long as I is less than str.length. And what do I do each time? I'm increasing I by 1. So I'm going 0, 1, 2, 3, and I'm done. It's really important. I could put here, instead of I less than str.length, I could put I is less than 4. But I always want to use the built-in method to calculate the length of the string. Because, right now we're figuring out the number of s's in the word fish, but maybe it's a different word that has a different length. So that means that if I change the word str, Java will account for the change in length. You always want to use the built-in length method to calculate the length of a word. Never actually count it yourself and put it in. Okay, let's look at it in reverse. So the first question is, what does the counter start at? So if I'm going to look at this in reverse and find the number of s's that appear, the counter is going to start at 3. But again, I don't want to put 3 there. I want to use the str.length operator, because if I put something in here other than fish, I want Java to account for that. So I do str.length and I subtract 1, because the length of fish is 4 and the first index is the last index is 1 less than the length. So now my question is, what is the change each time? Well, we see we stepped from 3 down to 2, and then from 2 down to 1. So I'm subtracting 1 from I each time. And the last question is, what is the last index? So what do we want to get to? And we want to get all the way down until I is greater, we want to continue as long as I is greater than or equal to 0. And this is how we look at this string, and we do the same analysis but in reverse. Usually when we have a problem, it's commonly at our start or our end points. So students will often hear say I is greater than 0, and then they'll leave that last index out. Okay, so now we're going to talk about some theory, and the idea is building a string. So sometimes we need to build a string from one or more existing strings. So imagine you had 2 words and you wanted to pull out some parts of those words to make another one. And like I said, we can't subtract letters from a string, and I say we can't do that easily. There's a way to give the impression that we're doing that, but for our purposes right now, we're going to say you can't do that. Therefore, a common technique here is to make an empty string and then add the parts we want to it. So for example, we want to write a short code segment that takes every second letter from str and uses it to create some new string. So for example, if str is excellent, the new string would be XELN. And we can see every second letter. So we want the X, we want the E, we want the L, and we want the N. So we're going to start off this process by first making a string called str and putting the word we want in there. And then we're going to make a second string, but we're going to put double quotes, meaning there's nothing in there right now. So it's an empty string. So I set my loop up because I know in order to find these letters I need to look in sequence. And I need to figure out what are the different values that go inside the loop. And I'm going to tell you that all I'm going to do to construct this string is I'm simply going to take whatever S is, so whatever S currently contains, and then I'm going to add the current character I'm looking at. So think of it like if I have my finger here and I'm pointing, I'm going to go X, I'm going to take that out and add it to S, then I'm going to move to E, take that out, add it to S, then I'm going to move to the L, take that out, add it to S, then I'm going to move to the N, take that out, add it to S, and I'm done. So my first question for you is, what is the index of the first letter we want? We want the X. The index of the X is going to be 1 because indexes start at 0. So that means I'm going to initiate my counter to 1. The next question is, if I want every second letter, what is the next index we want? So if I want this E here, that E is an index 3. So what have we done to go from 1 to 3? This means how much does the loop counter advance by? It's advanced by 2. So we're going to have our change by 2. Finally, when should this loop stop? Well, a better way to say this is not when should the loop stop, is what condition should the loop continue? And that is, as long as I is less than the length of the string, we should continue to process this string. So traversing a string. You know, in the last two specific examples, the last two slides, and sorry, this wasn't the last two slides, it was the last couple slides, so I should make a correction right here. However, what happened in the loop doesn't matter. You know, really, yes, we could talk quite a bit about the mechanics of what we do inside the loop, but what's important is we understand how to set up the loop to traverse a string. We always want to look at the string indices and modify the loop settings to alter the order they are accessed. So again, we always want to think about the string we have, think about those indices, and we're going to use the built-in length method to kind of modify the loop settings, so to speak. I am sure you've probably come across this error already, but we're going to say we need to watch for this. We need to watch for index out of bounds errors. And this next chunk of code here actually has one. Can you see it? So if you can't see it yet, let's walk through what happens here. So I have a string called str, which stores super. I have a string called s, which stores nothing. And then I start at index 0, and I go as long as I is less than or equal to str.length, and I add 1 to I each time. So I'm going to look at each character in sequence. Then I simply add that character twice to this string. So the way it works, when I is 0, s gets the value ss. Then I becomes 1, s gets the value ssuu. I gets 2, so we get ssuu.pp. And then I becomes 3, we get ssuu.ppee. I becomes 4, we get ssuu.ppee.rr. And this is where the problem is. Because I is less than or equal to str.length, when we're at the end of this loop here, I will become 5, and that satisfies the loop. So I end up pointing into this region where there's no letters, and that's what gives the index out of bounds error. Because I'm trying to do str.char at 5, and super has indexes 0 to 4, you get a runtime error. So students always say, okay, why do I need to know this? Besides the fact that actually, if you like doing puzzles, there's a lot of really cool little puzzles you can come up with. You know, it's interesting trying to count how many times a certain word shows up and all these different things. But string manipulation is a very important part of computer science. And one area we see this is in computational biology. So this is something I pulled from the internet, and you can click on this link here to where I got it from. I'll put it in my YouTube comment area. And what this represents is, this is the genome for essentially E. coli. And if we look at this, it's a number of nucleotides. Here they all are. And inside here, I can find, there are instructions for protein construction inside of here. And if I can find that, I can do all sorts of neat things. So by searching the sequence and identifying patterns, like I said, I can find them. And that's where strings and loops might come in useful. And people actually write programs to do this. In my grade 12 course, we write a selection of programs that will read genetic sequences and find possible protein constructions. And some people say, oh yes, well maybe I could do this just by looking. But note how many nucleotides there are. This is the first line, and this is the 17,000. Let's say 1,725,721st line. So you're not going to do this by hand. You're going to write some automated program to do it. So as always, please ask me questions, whether you're in my class or not. I'm happy to help, and I love getting them. They help me improve as a teacher. And if you're looking for somewhere to practice this, working through coding bad exercises is a great way to practice this essential idea. Specifically the exercises under strings too. Have a wonderful day.